Well, I must apologize first because you have to listen to me speak in English. But I am confident that your English skills are much better than my Spanish skills. So maybe we can agree that we'll get through it together. So I want to welcome you all to the In Real Life portion of the Quality Sense Conference. I am very grateful for the opportunity to speak to you today and hopeful that you will find something, even if it's only one thing, that is interesting to you and that you can take back to your company and to your customers. My name is Charlie. I spent 30 years in information technology, and I started my career as a developer, although my title was programmer. And I think that's like one step above typist. Based on the job title, you can get an idea of how the world thought about software back then. And over the years, I worked my way up through an IT career path: programmer, programmer analyst, support engineer, system administrator, project manager. Later, I moved into sales engineer role, followed by leadership roles in customer success, professional services, and most recently working with our channel and alliance partners. So today I work for a company called Datadog. And while we make a SaaS observability platform, this talk will not be about Datadog. Instead, I want to share some thoughts with you about the idea of creating or crafting quality software. There we go. Now we get a new slide. So right out of college, I went to work for a computer product manufacturer. And my first assignment was to babysit the company's manufacturing assembly line during the second shift. So I worked from 2 p.m. in the afternoon until 10 o'clock at night. And each station on the assembly line had a yellow light. And if ever the yellow light went off, I had to go find out what was wrong. So I was a babysitter. I had to investigate the problem. I had to see the signal, investigate the problem, and then try to fix it if I could. Our assembly line software was called SOE, Sequence of Events. I always thought that was such a great name. It was perfect because that's exactly what happened. We had each station in the assembly line, one at a time. Everything happens in sequential order, or a sequence of events. This software was written in a popular programming language at the time called DBase, and it provided instructions to the assembler at each station, which parts they should pick, how they should put them together, and record their progress in the system so that at any moment, the company knew where all of the part inventory was and all of the completed products and even the in-process products. We always knew exactly where everything was. The application was not fancy. It didn't have a graphical user interface. There was no mouse, but it was functionally excellent. It was very, very good. It was easy to use. The issues were rare. I didn't see a lot of those yellow lights, so made my job very easy. And the simplicity of the software made it very easy to maintain. It was modular, right? A piece for each station. And so it wasn't very complicated. Besides SOE, I worked on other interesting projects at that company. Oops, sorry. I wrote an application to print product and shipping labels using Zebra thermal transfer printers, if anybody has seen those. These labels, they often have regulatory information, barcodes, and they're used to keep track of parts and finished product within a manufacturing company. I learned how parts and inventory are managed. I learned ZPL, the Zebra programming language. I learned Code 39, a standard for barcodes. And I learned the difference between human readable information and machine readable information, and how to think about presenting machine readable information. Some labels had only a barcode, no other text, no other markings. And so it became important to understand physical size, constraints, and what is the most important piece of information, the detail that needs to be on the label. On another project, I was part of a team that deployed an engineering data management product. This was a fancy kind of version control for computer-aided design architecture diagrams. So the software that we purchased was made by a third party, but the developers were very clever, and they understood that customers would need to be able to extend the functionality of the product that they provided. And so in order to tailor the software to fit our needs, we were able to tap into these things called software hooks. We didn't call them APIs, but that's really what they were. They were early forms of application programming interfaces that allowed us to tailor or customize this software for our business. Now, I share this background with you because this period of time in my life was when I was introduced to two important things. And those are the things that I'll share with you today. First is the whole idea of software development. This is where I learned how to build software. And second, I was given a book, and we're going to use that as the basis of our discussion today. The book is called Zen and the Art of Motorcycle Maintenance. And if I could just ask anybody to raise their hand if you've heard of this book. You have. Ah, okay, good. Nobody else. Perfect. It's fantastic. So can I ask you, so you've heard of it?
I have read it.
Have you read it?
Many years ago.
Okay, so the last question is, did you understand it?
No.
Yeah. Excellent. All right. Well, I'm right there with you. This book was given to me by a friend in college, and I thought he was the smartest person I knew at the time. He was studying physics and philosophy, dual major. And I thought, who does that? Like, what? You're not going to have a job. What are you going to do? But he was very smart. He was a very kind person. And he turned me on to this book. And I have to say that over the years, I tried to read it multiple times. And every time I would get stuck and I just couldn't understand it. So it took me a lot of years of going back, rereading it, trying again, sticking with it. And finally, I managed to really sort of understand parts of it. But I don't want that to dissuade you from looking into this book. It really is very interesting. And this book was published in 1975, so it's a little bit old. The book, as I said, is a challenge to read. It is a philosophical inquiry. And I'm going to try to tell you what I learned from it today and talk about how what I learned from this book applies to software development. So hang in there. This is going somewhere. In the book, the author talks about quality at length, and he tells the story about a cross-country motorcycle trip with his son. It is very much a philosophical work. He is obsessed with understanding quality as part of this journey. And so this book is not about software development, but I think that it provides some insights into the nature of quality. And those insights can be applied in a meaningful way to the idea of modern software development. At least that's what I'm going to try to convince you today. But before we can discuss quality, we have a small problem. We have to figure out what the hell it is. And those aren't my words. That's right out of the book. So the author says, quality, you know what it is, but you don't know what it is. And that is self-contradictory. Some things you know are better than others, so they would have more quality, right? But when you try to say what exactly is quality, apart from the things that have it, it all just sort of goes poof, he says. So there's nothing to talk about. But if you can't say what quality is, how do you know what it is? And how do you even know that it exists? But if nobody knows what it is, then for all purposes, all practical purposes, it doesn't exist. But we all know that it actually does exist. So we're stuck with this problem. What exactly is quality? And we need to be comfortable a little bit with the idea that quality itself is elusive. And so we're going to try to unpack what quality is and how it relates to crafting quality software. So this is a framework, and this is a framework from the book. And I'm just going to kind of walk through sort of how this framework can help us understand quality. And then I want to connect the framework to the ideas of software testing and software observability. And maybe we'll bring it all together. So first, the book emphasizes the importance of what he calls the relentless pursuit of quality in all endeavors. And I want to pause for a moment. Relentless means it never stops. Pursuit means you're always chasing it. You might not catch it, and you have to be okay with that. It's like the pursuit of happiness. You can keep trying, might not always be happy. And in all endeavors, right? So it's not just quality in your sleep or quality in the way that you interact with your family, but it is quality in everything that the author suggests is important. And that is hard because sometimes I'm really grumpy. Sometimes I don't feel well. Sometimes I'm tired. I don't want to think about quality. I just want to get through that day, or I just want to finish the task that I'm working on. And I might not always think about quality when I'm doing it. Pirsig illustrates the concept of quality through what he calls the art of motorcycle maintenance. He emphasizes the idea that a craftsman who takes pride in their work and pays attention to meticulous details is engaged in the pursuit of quality, and that quality craftsmanship reveals a deep connection between the individual, the task, and the materials they're working with. So in software development, this means striving for excellence in every aspect of the process, from gathering requirements, doing analysis and design, coding, testing, measuring performance, and collecting user experience. All of these things, striving for excellence, is an expression of the quality of our intent. And this is where I think quality starts, the quality of our intent. Excellence, quality, experience. All of these words sound very subjective. You might have a different idea about what a good experience is than I do. And these concepts can even generate an emotional response. At Apple, the quality of intent was called surprise and delight. And they go to great lengths to ensure that no matter how you interact with the company, whether you call tech support, whether you open a box with a new iPhone, or whether you walk into a store, they want you to experience surprise and delight. So I want you to hold in your mind this idea of surprise and delight, and we'll come back to it at the end. But let's talk about subjective versus objective quality. So in his book, the author distinguishes between the idea of classical or subjective quality and romantic or objective quality. There's a saying in English that beauty is in the eye of the beholder. This is subjective quality or classical quality. But in software, subjective quality might relate to user satisfaction and the alignment with how the software works with what the user needs, what the user is trying to do. And so often we care about how happy they are, how satisfied. Does the software help them, or does it make them frustrated? Objective quality relates to measurable attributes. For example, the number of errors that occur when the software runs, or performance metrics such as how much CPU, disk, and memory are being used when the software is running. And finally, measuring reliability over a time period, right? So over a week, 30 days, a year. And as we think about modern software development, it's important to recognize the importance of both. Subjective, user-centric, based on feedback from the users, but also objective. What is the software? How is it performing? What is it costing us? What errors are happening? What security signals are we seeing in our running software? Next, Pirsig talks about value and purpose, and the connection between quality and the value or purpose of a product. So this gets to why. What is the purpose of the product? What is it supposed to do? Why does it have to exist? Why does anybody actually care? Because if we don't understand why the product exists and what its purpose is, then we won't be able to understand if the product is delivering value to the user, because one of the ways the users interpret value is, does it do what I think it is supposed to do? When I push the button to call the elevator, does the elevator come or not? By the way, if you try to push the button multiple times really fast, that actually doesn't make the elevator come any faster. I don't know why that is. Seems like a user interaction problem. All kidding aside, so in software, quality is tied to this idea of the value that the software delivers. And the value is related to how the users perceive the purpose of the software. So what do they think it's supposed to do? And if you think about the software you use every day, right? What is the purpose of that software? So some examples, right? Is it trying to help you find information? Google, Bing, other search engines. Is it trying to entertain you, right? Music streaming, videos, books, Is the purpose to enable a customer to buy other products from us? E-commerce, right? So if you think about how well in your own life that software fulfills its purpose for you, you probably will recognize that you choose these services based on your perception of how well they do the job. Does anybody shop at Amazon? Amazon.com? Maybe a few? Okay. Gets the job done, right? You find the product, you find a good price on it, you hit the buy now, and magically in the US, sometimes hours, it's a little scary, but very quickly, you get the thing that you want. And if you don't have a lot of time, or it's hard for you to get to a store, right? Amazon is delivering substantial value to you, and you choose to be their customer because of that value. Attention to detail is important as part of this framework. The author describes how on his road trip, a simple oversight in tightening a single bolt on the motorcycle's engine had profound consequences, and not good ones, for him. He recounts an incident where he noticed that a bolt was loose, and he decided to tighten it. But he did it quickly. He wasn't paying attention. And it turns out that bolt has specific torque specifications. He over-tightened the bolt, and he caused it to shear off. So now, not only does he not have a loose bolt, he has no bolt. This is a problem with the motorcycle. And so the idea is that what was a simple problem and really a simple mistake actually turned into a critical task that prevented him from continuing his journey. So this story emphasizes that even small or minor elements, little details, can have a significant impact on the overall quality and performance of a system, whether it's a motorcycle engine or a piece of software. And for us in software development, the lesson is clear that neglecting these small details can lead to unexpected and costly consequences. So this means that attention to detail is a fundamental aspect of our craftsmanship and our pursuit of quality. These details come to us in software in the form of code standards, deployment models, business process, operational process, and standards. And all of these require attention to detail. Code reviews, pair programming, testing, observability, all of these things play a role here. And of course, insufficient detail in coding, insufficient detail in testing, insufficient detail in observability, all of these things lead to problems that are lurking and are unseen. And then we hand them over to the users. And the best testing that happens is right there. Because in that moment, the user who is trying to determine if the software you've given them has value, right? They were going to find that hidden detail. They always do. The author in the book talks about how pursuing quality is also a balance between art and science. So when I say those words, like who hears that and thinks, yeah, art and science? Excellent. Everybody else is like, no, it's science. Or no, it's art. The author talks in the book about teaching a college-level course on creative writing. I took a college-level course in creative writing. It was very interesting. But he presents two different approaches to creative writing. So the classical or scientific approach is that some students are inclined to follow a very structured, analytical approach. They adhere to rules of grammar and composition They rely on a systematic formula to produce their work. Maybe they start with an outline and they do their research on each category and they create bullet points. It's all very organized. I do not write like that. I'm more the romantic approach, the artist. At least maybe it's aspiring to be an artist. Some students approach writing from a more intuitive or artistic perspective. So you prioritize creativity and imagination and expression and big ideas over strictly adhering to the rules. So whether it's passionate and it may be artistic, it might actually lack some precision. It might lack some clarity that you would see with the classical approach. And so the point of introducing these two styles is to recognize that writing is writing, and quality writing can include concepts both classical, structured, organized, but also expansive and creative and imaginative and artistic. So in software, our challenge then is to balance creativity and innovation with structured engineering practices, right? Doing things in a repeatable way, a scalable way. So there is a nice balance that we can find between functional and elegant, between art and science, and maybe even user interaction, user experience. These are some of the areas where we can truly express creativity in terms of software development. Quality is not static, the author says in this book. It's always changing. It's evolving, circumstances change, the world changes, and he talks about how his motorcycle initially runs smoothly, right? It's perfect, brand new, out on the open road, feeling good. But over time, he starts to notice a decline in performance as the machine just gets, used. Normal wear and tear, tires, shock absorbers, gasoline, the engine, all of these things start to just slowly change over time, and they impact his experience. And so those factors, wear and tear, changing weather conditions, and other adjustments that he makes during the process of maintenance of his motorcycle, these all impact the quality or the pursuit of quality that he's on this journey. And so for us, it means that we need to think about embracing agility and adaptability and understanding that our world too, is always changing, right? The way that we used to deliver software and design software, right, in the olden days, we would gather the requirements, we would go off and design something, and then we would architect it, then we would build it, and then we would come back and hand it to the users months or years later and say, look what we built for you. Isn't this great? Aren't you happy? Aren't you wonderfully surprised? And most of the users would say, actually, that was 2 years ago. That would have been great. But now I've moved on. I have different requirements. I have different needs, and your software doesn't work for me. And now we're stuck with this problem of that software is very expensive to go back and rework, to fix it, to make it what the user wants. And so, so for us, I think we've learned this lesson in software development, right? That's why we think in terms of agile. That's why we think in terms of smaller units of functionality. That's why we think of modular code. That's why we think in terms of sprints, not decades, when it comes to writing software. So I think this is actually really good. The software industry has learned this lesson that, hey, the world's not a static place. You can't stand around and just assume everything's going to be the same. You've got to constantly be looking around to see how it's changing. In our framework, it should change to the, there we go. He talks about philosophical inquiry as the basis for pursuing quality. So he's obviously a philosopher. He's on the back of a motorcycle. He's with his son, and they're on the open road. That's a great combination for doing a lot of thinking, right? thinking about the world, philosophizing about how the world works and how it should work and how it doesn't work and all of these things. And he sort of comes around to an idea that you should be able to question assumptions, right? So for us, again, question assumptions. One of the assumptions that I learned along the way in my career is I had an assumption that when I asked a customer or a user or a colleague to tell me, help me understand how you're trying to use this thing, I assumed they were telling me the truth. Now, I had the opportunity to work for a manager who said, everybody lies. Everybody lies all the time. You can't trust anybody. I thought that was a bit extreme. But what he did point out to me is if you don't question the assumption, right? So in my case, the assumption that everybody's telling me the 100% truth, right? If you don't question that, then what you never find out is that, for example, if you ask someone, hey, I would like to build a synthetic test that loads a website, navigates through some of the fields, enters some information, hits enter or submits the data and checks the result. I want to build this test for you. Will you show me how, as a user, you go through those steps? This seems really easy, right? Should be no problem. What you find out when you question the assumption that everybody tells you the 100% truth, humans often, we skip over little details because we don't think they're important. And unless you sort of assume, hey, walk me through step by step, what you see is, okay, I load the web page and I navigate to this, and then I click on that thing. Oh, I noticed that you always change it from English to Spanish. Why do you do that? Oh, yes, okay, I didn't tell you about that. Well, okay, that's an important step because maybe the data or the code or just the page, the language is going to change. So it's going to come from a different file perhaps. And so the impact of something small that I assumed the user would just tell me, they didn't think it was important enough to tell me. This is also part of seeking truth and understanding as part of the philosophical inquiry, right? Having the user really help you understand, what do you do step by step, and how can you recreate that to understand a user interaction with a website. He talks about the importance of critical thinking and analysis. So in software testing, testers employ critical thinking to design test cases, identify potential risks, assess the impact of changes, and observability requires analytical skills to interpret the data and diagnose those issues accurately. Continuous reflection and improvement. So philosophical inquiry involves ongoing reflection, refinement of one's understanding. And similarly in software development, testing is iterative. Testers continually assess and refine strategies based on new information, new requirements, and observability contributes to this cycle of improvement by providing real-time feedback. So we see a connection there between the philosophical inquiry, continuous reflection, and improvement, and how testing and observability play a role there as well. Philosophical inquiry often seeks a holistic perspective, big picture on complex issues. And in software development, observability can give you that same kind of holistic overview of how the software behaves, monitoring various aspects like performance, user interactions, system health. And this comprehensive perspective aids in understanding the quality of the software from multiple angles. Finally, as part of philosophical inquiry, the author talks about integrating knowledge from various disciplines and perspectives. And so similarly, if we think about bringing in different perspectives in software testing and observability, We think about various sources, diverse sources of information, including direct feedback from users, and no two users will necessarily provide the same perspective. The metrics, traces, logs, the telemetry, what I call the machine data, the data from the software, from the infrastructure where it's running, from the databases where it's being stored, all of this data, log data, all of these things are different perspectives that need to be integrated into a holistic picture of what's happening. And last but not least, in the book, the author talks about something he calls gumption. Has anybody heard this word gumption? It's a very esoteric is an esoteric word. Gumption, with the author, he says, I like the word gumption. It's so out of style that it looks like it needs a friend. And it is not likely to reject anyone who comes along. It's kind of a fun way to think about a word. It's this lonely little word that is just waiting for a friend. But it means drive. Some people call it grit, perseverance, stick-to-itiveness. Ugh, I don't like that word. Ugh. But the author calls gumption psychic gasoline that keeps the whole thing going. And I love that, in addition to the idea that gumption is kind of a lonely word. But it's this inner drive, it's a determination to tackle challenges, to dig deep into problems, and to really understand root causes. And the author goes on further to talk about gumption traps, like when you get stuck, you lose your grit, you lose your perseverance, you get demotivated, your energy goes low, and you feel, I can't do this. But gumption is what helps you keep going. And so what he's saying is that gumption traps are mental and emotional roadblocks that hinder our ability to engage fully and solve problems effectively and pursue quality in every aspect of life. And so if we can recognize and address these traps as an integral part of this philosophical exploration, continuous learning and continuous improvement are the key to helping us avoid those traps. So in software development, this means that teams should similarly apply continuous learning, continuous improvement to identify and overcome obstacles that impede quality. What is the number one thing we talk about all the time is technical debt. Has anybody in the room got any technical debt they're living with? I got plenty. It's my inbox is full of technical debt. This is the thing, right? We build something and then we decide it's done and we go move on. And we now have a new project and a new thing, and pretty soon that old thing comes back around and starts to haunt us. So let's try to put it all together. How much time do I have? Not any. Woo! All right, let's bring it home. There's a lot of philosophy. Let's try to bring it home very quickly. So let's talk about how modern software development, testing, and observability specifically. I just want to be clear. I think coding is actually important, right? An important contribution to quality. So if you have bad algorithms, if you have the wrong languages for the right project, you can make lots of good or bad decisions in coding that impact quality. But for the purposes of wrapping up quickly, I want to talk more about testing. And I won't go into all of the details because you guys are the experts in testing. I am not. I want to simply point out that when we think about testing, we have lots of options, right? And so if we think about attention to detail and the pursuit of quality and all of the philosophical things that we just talked about, we see that each of these types of tests actually reflect those principles. And so we can connect the real world thing that we do to the philosophical understanding that we have of quality and how these types of tests, for example, help drive our approach to quality. You can read the idea here on the slide, but the point is that it's not enough to do just basic testing. We want to be rigorous. We want to be repetitive. We want to be scalable. We want to pay attention to the details. We want to go over and over. We want to look for all of the different types of testing that are possible. And that is, being rigorous is what leads to quality. It's not, well, we did a unit test and everything looked fine. It's being rigorous with our approach to unit testing that's important. All right, I'm gonna kind of skip ahead. Does everybody know what observability is? Have you heard this term before? A few people. Some people have think of it as monitoring. Yeah, everybody's got monitoring. Okay. We think about observability slightly different from monitoring. Monitoring is kind of an out-of-date term, but observability really is the idea that you can discern the internal state of a system by looking at external measures and signals. So what you're interested in is what's happening in the software, what's happening inside the host, what's happening in my EC2 instances, what's happening in a serverless function. And the way that we figure out what's happening is by these external signals and measures. We look at the world of observability through dashboards. And the most important thing that dashboards give us are real-time insights into what's happening, right? How's the software performing? Are there errors? How are the users interacting with our software? But observability also gives us the ability to diagnose performance bottlenecks, detect rapidly issues that are happening and figure out how to resolve them quickly, provide root cause analysis so that we can understand what ultimately needs to be fixed in our software, and provides a basis for continuous improvement. So that was a really fast way to speed through from the philosophy to the testing to the observability. But what I want to do is just encourage you to think about how the author perceives quality through that framework, and how that framework is aligned with many of the activities that we carry out every day as testers, and every day when we think about the observability of our software. And ultimately what we're trying to do is deliver quality software. I titled this Crafting Quality Software because I think it is a craft. And I think that's what resonated with me in the book, is that the author thinks about craftsmanship and that notion that there is a scientific aspect of it, there is a structured aspect of what we do, but there is also beauty, and there is also imagination, and there's also creativity. And I hope that you take all of those things with you as you deliver quality software to your customers. So thank you, Abstracta, for letting me speak, and especially for letting me speak a little long. Thank you all for caring about
Thank you so much, Harley.